Hello all, good evening. Can you all hear me?
Yes, ma'am.
Yes. So let's start today's session. So today's session is for week 9 Solve with Us. So you have to go to joinpd.com and use the code WTPAU. So once you go to joinpd.com and use this code, you will see this page. Okay. So I will just wait for like 1 or 2 more minutes so that people who haven't joined it, please join it, okay? Okay, so let's start the session now. So this is our first question. The question says, let x1, x2, xn be NIID samples from a distribution X with mean mu and standard deviation sigma. So what does it mean is like you have an ID sample which is coming from distribution X, and the distribution X has mean mu and standard deviation mu. And since all the samples x1, x2, xn are IID and it is coming from X, their mean and standard deviation will also be mu and sigma respectively. Now you have defined an estimator of mu, that is mu hat, that is given by 20 times sample mean. Okay. Now, given this estimator, you have to check what is the risk of this estimator mu hat. So you have to select one option from there. I'll give you a few minutes. Is the question clear to everyone? Others who have not who have not gone to joinpd.com, please go to joinpd.com and use the code WTPAU to answer on PeerTech. Okay. Anybody else want to answer this? So far, we have 9 out of 19 responses. Others who have not joined, please go to joinpd.com and use the code WUTPAU to join the session. Okay, so most of the people have answered option C. Anyone would like to answer this question? Am I audible?
Yes.
Yeah, madam. Yeah.
Okay. So anyone would like to explain how do you find the risk of an estimator?
Ma'am, we will use plus variance of the estimator, variance of new hat.
Okay, so what is the bias that you got?
It will be 19 new.
You're getting bias to be 19 new. Okay.
Yes, ma'am.
And okay,
Yeah,
let's
only by seeing 19 new, we answered C.
okay. So let's look at the solution. We know that we have to find the risk, we need to find the bias and variance of the estimator. So first of all, how do you find the bias of an estimator? The estimator is given by mu hat, and it is an estimator of mu. So to find the bias of an estimator, we need to find expected value of the estimator, and we need to subtract the expected value of estimator from the parameter itself. Okay, so we have to find, since we have to find the bias of mu hat comma bias of mu hat, so we'll find the expected value of mu hat. So mu hat was given as 20 times x1 plus x2 plus up to xn by n, and expected value will come out to be, since all these xi's x1 to xn are IIDx whose expectation is x and standard deviation is sigma. So this expected value of x1 plus x2 plus xn will come out to be n mu. So 20 times n mu divided by n, and you get expected value of mu hat to be 20 mu. Now to find the bias, we have to subtract. Bias is basically expected value of estimator minus the parameter. So here it is expected value of mu hat minus of mu. So it is coming out to be 19 mu. So we found the bias. Now we need to find the variance, right? So variance of mu hat will come out to be 400 sigma square divided by n. Okay. So what is risk? Risk is bias square plus variance. Now we found the bias that is 19 mu. So square of it will come out to be 19 square is 361. Okay, so bias square plus variance of mu hat. So you will get 361 mu square plus 400 sigma square by n.
Ma'am?
Yes.
Just a small doubt. Whatever you have explained, that is clear.
Okay.
Just a small doubt. Generally, we also define risk as, you know, expected value of square of error, right?
Risk is expected value of
square of error. That is the first principle definition, right? Risk is the expected value of square of error. E of, you know, error is theta hat minus theta whole square, right?
error is expected value of theta hat minus theta whole. Yeah.
No, error is theta hat minus
Theta hat minus theta, right?
And bias is the expected value of error, and risk is the expected value of square of error. That's why it is called mean square error, right? So if I approach this problem through that method, then how will I get the answer? Like expected value of theta hat minus theta whole square.
Can you try? Did you try that method?
Yes, I approached to that method only, so I got stuck.
Okay, so what answer did you get?
It was coming, some sort of a minus b whole square formula. Like it is theta hat minus theta whole square, right? Expected value of theta hat mu hat minus mu whole square. So I started, getting into. So, but this method is also clear. I know you have used the formula that is equal to Bayes square plus variance.
Hmm.
So what is wrong in that method, ma'am? Why?
Okay, let's wait. Okay. Just give me a minute.
No problem, ma'am.
Yeah. I will. You should get the same answer. Hmm. So,
Yes, ideally I should get it, but I got stuck somewhere.
okay, so
No
what?
problem. We can discuss later on also, ma'am.
Yeah, we'll discuss
Yes,
it
yes.
at the end. You should get the same
Yes,
answer.
yes, yes. That's why I'm wondering. So I thought to check it. No problem.
Okay, let's discuss it at the end. I will take
Yes,
it at the end.
yes, ma'am.
So, any other doubt in this explanation? Any other doubt? Okay, let's move forward. So, in the second problem, we have let x1, x2, xn is IID x, where x is a random variable with density function given to you, and it is defined as theta upon x to the power theta plus 1 for x greater than 1. Otherwise, it takes the value 0. Now, from this distribution, you are taking one sample, that is 3, 6, 2, 7, 8, 10. So what is the maximum likelihood estimate of theta for the sample? Basically, your parameter here is theta, and you want to estimate this parameter. You have taken a sample from this distribution, and now using this sample, you have to find what is the maximum likelihood estimate of theta. I will give you 5 minutes to solve this problem, then we'll discuss. Any doubt in this question? So far we have only 8 responses. We'll wait for 1 more minute, then we'll discuss, okay? So please write your answer in peer deck. Okay, so should we move to the answer? I could see only
Yeah.
11 responses. So all those people who I could see some 54 participants here. So all those people who have not joined the peer deck, please go to joinpd.com and use the code that you can see on the top right corner of the screen. That is WTPAU. And if you are in the peer deck, please write your answer in the peer deck. So, okay. Okay, so most of the answers are between 0 to 1.25. Okay. So how would you find the maximum likelihood estimate of a parameter? So what is the definition that we use? What is the definition?
We take the
multiply all the density functions.
Argument of multiplication of all the density functions.
Yes, you need to find the argument of it, right?
Yeah, yes.
So density function is given to you and you have the sample, okay? So the sample is 3, 6, 2, 7, 8, 10 and the density function is theta divided by x to the power theta plus 1 for x greater than 1. Now, we know that given a sample, the likelihood function is defined as product of the density function for each of the sample points. Now we know that all these xi's are coming from the distribution x, and that PDF is defined by theta divided by x to the power theta plus 1. So for I varying from 1 to n, we have to product all these density functions. We have to product this density function for all those xi's. So once you do it, you will get something of the form theta to the power n into 1 by x1 to the power theta plus 1 times 1 by x2 to theta plus 1 and so on. So what are x1, x2, xn here? So if you go back to the question itself, so what is x1, x2, x3, x4? Can you find out what is x1, x2, x3, x4 and all that?
Samples 3, 6 to 7.
3, 6 to
Yes.
7, 8, 10.
Yes, right. So these are the x size value. Now what you can do is, instead of going till n, you can just take these 6 sample points and you can just find it. So going through n is it will look a little complicated. So what you can do is, since you have just 6 sample points, it will come to the power 6, 1 divided by whatever the value of x1 you have, you put there, theta plus 1, then 1 divided by whatever value x2 you have, put it there, theta plus 1 and so on. So you will have some 6 term, because the sample is 3, 6, 2, 7, 8, 10, right? Now once you find the likelihood function, you do the log likelihood, right? So you take the log of theta to the power n 1 divided by x1 to the power theta plus 1 up to so on. So once you take the log, you know that log of a times b becomes log of a plus log of b, right? So here theta to the power n is, let's say, is the first term, and the term in a bracket is the second term. So once you take the log, it will become log of theta to the power n plus log of 1 by x1 to the theta plus 1 times 1 by x2 to power theta plus 1 and so on. So you also know the property of log, that log of x to the power n becomes n log x, right? So log of theta to the power n will become n log theta, right? And
Excuse me,
sorry.
Instead of writing x1 raised to theta plus 1, like that, we can write x1, x1 into x2, etc. xn raised to theta plus 1. Then we can easily write it as.
Can you repeat?
Instead of writing log x1 plus log x2.
You can take, you're saying we can take this theta term common, and we can just write x1 plus x2, right? This is what you're saying.
Not that, x1 into x2 into xn raised to theta plus 1. We can write it as.
Yes. That would be easier, right? Like in calculation, that would be easier. Okay, so right now we have 1 divided by x1 to the power theta plus 1 times x2 theta to the power 1 plus 1 times xn theta to the power xn to the power theta plus 1. So this, the whole thing in the denominator, this you can write it as x1 times x2 times xn, then x1 to the power x1 to the power theta times x to the power theta. You can just split it and write it in that way. So okay, so is the step clear? Like going from likelihood function to log likelihood. Is this 2 steps clear? Are these 2 steps clear? Going from likelihood to log likelihood.
Yes, ma'am, it's clear.
Okay.
Simplification is not clear.
Sorry.
The simplification we have here. So, 1 by x1 theta plus 1 into 1 by x2 theta theta.
See, okay. This you look at just likelihood function. Okay, for now, likelihood function is given as theta to the power n times 1 by x1 to the power theta plus 1 times 1 by x to the power theta plus 1 up to 1 by xn to the power theta plus 1. Okay, so denominator term, you can write it as x1 times x2 times x3 times up to xn to the power theta plus 1. This you can write, right? X1. Your voice is not very clear.
Yes.
So you can write now, since x1 x2 up to xn to the power theta plus 1. Okay. Now you take it to the numerator part. So once it goes to the numerator, it becomes x1 x2 xn to the power minus theta plus 1. Okay, so once you take the log of this whole term, got it?
Yes, ma'am.
So it will become minus of theta plus 1, then log of x1 plus x2 plus up to xn. Right? So once we found the likelihood function, after that we go for log likelihood. So we found the log likelihood. Then what exactly do we have to find? We have to find such theta that maximizes, right? So that maximizes the likelihood function. Now, what you have to do is you have to differentiate, right? You have studied that in maths 1 or 2, I guess. You know the differentiation. You know how to differentiate?
Yeah.
Yes.
So now you have to differentiate your log likelihood function with respect to your parameter, right? So we know to find the maxima, minima, what we do, we differentiate it with respect to the variable and then equalize it to the 0 and then find the x or y value. So similarly here, instead of our x and y, we have the parameter theta. Okay, so what we are doing here is we are differentiating our log likelihood function, that is n log theta minus theta plus 1 log of x1 plus x2 log of x2 plus up to log of xn. So we are differentiating this log likelihood function with respect to theta. So once you differentiate it, what will you get? You will get, for the first term, you will get n upon theta. For the second term, you can see that this log of x1 plus log of x2 plus log of xn, this is going to be a constant term, right? Because it doesn't involve theta. So we can pull it out and we can just differentiate this theta plus 1. So it will become n by theta minus of log of x1 plus log of x2 plus log of xn times minus 1, right? So it gets n by theta minus of log of x1 plus log of x2 plus up to log of xn. Is this clear till here? Till differentiation part?
Yeah.
Sorry?
Understood.
Okay, yeah. So once you differentiate it, you put it equal to 0. So after that, we are getting theta equals n upon log of x1 plus log of x2 plus up to log of xn. So what is this x1, x2, xn? We know that it is 3, 6, 2, 7, 8, 10, right? So we just have to substitute it there and you will get 6 upon log of 20160. So once you solve it, you get theta star, theta hat to be equal to 0.60. So are you all getting the same answer, 0.60?
Yes, ma'am.
Yeah, okay. So how to find the maximum likelihood estimate? This is clear to everyone. So the first thing that we do is we find the likelihood function, that is the product of all the distribution distribution function of the sample, and then we take the log likelihood. And since we have to find such data that maximizes likelihood, we differentiate the likelihood function with respect to the parameter and then equate it to 0 to get the value of the estimate. Okay, if this is clear, we'll move to the next problem. Okay, so now we have the sample.
Can you just go to the previous step for a minute?
Yeah.
This simplification log of each of these points. We just before the previous
Okay.
step, the previous here just a minute. So we are equating this to 0 and getting the theta value to be equal to n by this one, and then this implies the theta. The estimate of theta, right? Theta star means
Yeah.
it's n by, and we replace this n value n
With the samples that you have. So 3, 6, 2, 7, 8, 10.
okay, n, so n will be equal to the number of samples.
Yes.
And then
I mean, you have one sample, but I mean, sample of size 7, 6.
So we take this to the base of which log of these things to the base of we need to take natural log.
Yes. Yeah, sorry, can you repeat?
For which base we have need to take log to the base natural logarithm or log base 10?
Natural log. Natural log.
Okay.
Yeah. Okay, so again, the next problem is to find the maximum likelihood estimate. But in this case, the sample is coming from the binomial 4P distribution. So if you're observing a sample of 2043, what is going to be the maximum likelihood estimate for P? When you know that the sample is coming from a distribution with binomial 4, P. Okay, so this question is very similar to what we have solved previously. Instead, okay, so the process is same. Let's look at the responses first. Okay, most of you got P to be 1. Okay. So again, here we are doing the same thing. Like you have to find the maximum likelihood estimate of P. So we'll first find the likelihood function. So to find the likelihood function, we know that the distribution function of binomial is given by n choose x p to the power x 1 minus p to the power n minus x. So here n was already given to us, that was 4. So we can use this n, and so the distribution function becomes 4 choose x p to the power x 1 minus p to the power 4 minus x, right? To find likelihood function, we'll have to do the product of all the samples that we have, like the product of distribution function. So if you have this a particular sampling, that is x1, x2, x3, x4, for that particular sampling, you are getting 4 choose 1 to the power x1, 1 minus p to the power 4 minus x1 times you will do the x4, right? After you find the likelihood function, so okay, we already had the sample that was 0, 2, 4, 3. We can directly substitute it, and we get the likelihood function to be 24 times p to the power n 1 minus p to the power 7. This is the likelihood function that we got for the sample 2043. Okay. Now, after you find the likelihood function, what do we do? We find the log likelihood. So once you do the log likelihood here, it becomes so 24 p to the power n 1 minus p to the power 7 was likelihood function. You do the log, you take log of this, so it becomes log of 24, okay, plus 9 times log of p plus 7 times log of 1 minus p. You can consider this 24 as 1 a b to the power 9 as b, and 1 minus b to the power 7 as c. So log of a times b times c becomes log of a plus log of b plus log of c. So this is what we have used here, and we got log likelihood to be log of 24 plus 9 times log of p plus 7 log 1 minus p. And once we find the log likelihood function, now we have to maximize it, right? We have to find such p that maximizes the likelihood function. So once we differentiate, so in order to do that, we differentiate the log likelihood with respect to the parameter p. Once you do it, you get see, log 24 is going to be 0. If you differentiate with respect to p, you know this is a constant, so derivation of constant is 0. 9 times log of p becomes 9 by p plus 7 times log of 1 minus p becomes 7 times 7 divided by 1 minus p. And since for p we have the constant minus 1, so this minus 1 will get multiplied, and we will get 9 by p minus 7 by 1 minus p. Now we have to put this equal to 0 to get the value of p. Once you do it, you get the p of like p hat Binomial estimate of p to be 9 divided by 16. So 9 divided by 16 comes out to be 0.5625. So how many of you are getting 0.5625?
Yes, ma'am, I got it.
Okay. Others?
Ma'am, I got it too.
Yes, ma'am, 9 by 16.
Ma'am, can I say something?
Yes.
Ma'am, when we write the likelihood function of this binomial, we are writing 4cx and then the probabilities. So if we can skip that 4cx part, because that is not playing any role in the
yes. Yeah. 24 is it is
that is becoming constant at the end.
Yeah,
so
right.
From the beginning, if we can skip that, our calculation will be small, and also it will take less time.
Yeah, we can do that, because 24 is anyways a constant. So
yes, differentiating it will come to 0.
Yeah, all those n choose x term is going to be a constant, so we can skip that part. That is true, because yeah, it is not going to play any role here.
Yes.
Yes. Okay. Any doubt? Should we move to the next problem?
Yes, ma'am.
Yeah, okay. Okay, so here in this problem, we have to find the bias of the estimator. So what is the estimator defined here? So you are taking a sample of 5 random variables, that is x1, x2 up to xn, and n is greater than 30. We are saying n is greater than 30. And expected value of each of the xi's is given to be mu, and variance of each of the xi is given to be sigma square. And mu and hat is given to be the estimator of mu. Okay. And this mu and hat is defined as 1 upon n minus 30 sum over xi, where I is varying from 31 to n. Okay. So what is the bias of mu hat n? So you have to find the bias of mu and hat. Okay. So again, to find the bias, you know the formula, just plug in the formula and try to solve it. Okay, so let's see the solution. You could see most of you have answered it to be 0. Okay. So to find the bias of an estimator, we need to find expected value of
Error.
error, right? Yeah.
Yes.
So mu hat was defined to be 1 upon n minus theta, n minus 30, sum over xi. So since n minus 30 is a constant, we can pull it out, and sum of xi. And this is varying from 31 to n. This I is varying from 31 to n, right? So this is going to be nothing but n minus 30 times mu.
No. Voice is not audible.
Sorry, can you repeat?
Why is it n minus 30, man? Okay, just because it starts with I is equal to 31, xi 31. Does it mean the other 30 terms are no longer there? How is that?
Yes, yes, yes.
Oh, see, here it is said that n is greater than 30. Okay.
Correct.
So n greater than 30 means your I should vary from, so basically
31 on.
your random variable is going to be x1 plus x2 up to xi, and this I should vary from 31 to n. So if you have to find the expected value of sum of xi, I varying from 31 to n, so you will do x31 plus x32 plus x33 plus up to xn.
So the first 30 are not considered.
First 30 are not considered.
Okay, got it. Thank you.
So here expected value of this mu and hat becomes, it becomes mu, and we are finding the bias of the parameter, bias of the estimator mu and hat. So it comes out to be, bias comes out to be mu minus mu, and it becomes 0. So the bias of mu and hat is 0. Okay, any doubt in this?
Can we go to the solution page now?
Solution page, yes. Yeah. So the slides will upload on the portal, so don't worry about it.
Okay, ma'am.
Yeah. So the next problem is again from the maximum likelihood estimation. It says you have a sample that consists of the values 15, 16, 10, 8, 7, 9, 20, and 90. So overall, it is a sample of size 1, 2, 3, 4, 5, 6, 7, 8. So you are taking a sample of size 8 that is coming from a population that has the density e to the power minus xy theta divided by theta for x greater than 0. Otherwise, it is 0. Okay. So looking at this function, can you figure out what kind of distribution it is?
Exponential.
Exponential, ma'am. Exponential.
Yes.
Exponential.
Yeah. So Okay, so this is nothing but an exponential distribution with the parameter 1 by theta, right? Now, what you have to find here is find the maximum likelihood estimate of theta. Okay, so most of the answers are at 13, as you could see. Now, okay, so we identified that if the random variable x here has the exponential distribution and with the parameter 1 by theta, and we have to find the maximum likelihood estimate of theta. The sample is given as 15, 16, 10, 8, 7, 9, 20, 19. And so the same thing we'll do here. We first find the likelihood function, right? So to find the likelihood function, we need to multiply we have to find the product of all those distribution function. And once you do it, it comes out to be 1 upon theta to the power n e to the power minus of sum of xi's divided by theta, right? And after you find the likelihood function, you have to do the log of likelihood. So log of likelihood comes out to be minus of n log theta minus, you know that log of e to the power x comes out to be x, right? So overall it comes to be n log theta minus x1 plus x2 plus xn divided by theta. Now after you find the log likelihood, we have to differentiate, right? So now we'll have to differentiate the log likelihood function, that is d upon d theta of minus n log theta minus of sum over xi divided by theta. So n minus n of log theta becomes minus of n by theta, and 1 upon theta, you know, the derivative is 1 upon theta square, right? So sorry, minus of 1 upon theta square. So the derivative of the second terms becomes sum over xi divided by theta square. And after you differentiate with respect to the parameter, you have to substitute, and once you substitute, you get it to be the equal to sample mean. You get the maximum likelihood estimate of the parameter theta to be equal to sample mean. But do you remember that if you have an exponential function with the parameter, let's say lambda, so what does the maximum likelihood function comes out to be? Let's say x is a random variable and x follows exponential distribution with the parameter lambda. So distribution function becomes lambda e to the power minus lambda x. Now, if I ask you to find the ML estimate of lambda, what does it come out to be? Anyone remembers?
One by lambda.
Sorry, 1 by?
Oh, sorry. Nothing. Sorry.
Okay. Anyone? Do you remember what does it come out to be? N by sum. Yes. So when it is exponential distribution with the parameter lambda, and you had to find the ML estimate of lambda, in that case, the ML estimate comes out to be reciprocal of the sample mean. But here we have noticed that here the parameter is 1 upon theta. So once we find the maximum likelihood estimate of theta, it will come out to be like just the sample mean. So if you know, if you knew what is the ML estimate of an exponential distribution, ML estimate of the parameter lambda, where x is a exponential distribution, then you could like without even solving could have written it is sample mean here, right? Now we know the sample values. So the sample values is 15, 16, 10, 8, 9, 20, 19. You just have to submit all this and just find the sample mean, and that will come out to be 13. So any doubt so far? This was our last problem. So if there is no doubt, we can close this and we can take some open
We can discuss some activity question, ma'am.
Activity question. Okay,
Yes,
which
yes.
week?
Of this week only, ma'am.
Of this week only, okay.
Yes, yes.
It was not discussed in the last
No, it
session.
was discussed. After that, I solved some problem and I'm having some very basic doubt. I'm getting stuck at some point.
Okay, we'll come to it. Let's so before we close this, so any doubt in this whole slides? Any problem in the next slides? Anyone?
No doubt, ma'am.
Okay.
Just one observation, ma'am. Like we have not solved any problem related to MME and two parameters.
MME, okay,
And
here we have
MME,
not solved.
MME and ML involving two parameters.
ML estimation in two parameters, okay.
Yes. It's a good thing for us if we don't get those questions in entrance exam also, then that's a good thing.
Okay, so how many of you tried to find the ML estimator and the ME estimator for normal distribution? Like a normal distribution, you have two parameters, right? Mu and sigma square. Same goes for binomial. There you have two parameters. So how many of you tried solving ML estimator of sigma square when you have a normal distribution and method of moment estimate of sigma square? So it was given as an exercise for you to do it. Did try? Anyone tried?
Well, I tried for MLE, but I didn't try for the methods of moment for normal distribution.
Okay, so what answer did you get?
Just a minute.
It's a okay. I know it's a little complicated formula at the end.
Ma'am, for sigma square, it was summation xi minus nu the whole. No. Yes, ma'am, I got it something like the summation xi minus nu the whole square upon n.
I hope that is not the complete one. Something
Ma'am,
is
are you
missing.
asking for the likelihood function? And the probability?
Okay, well let me close this first. Okay, so we can take some common doubt. So Ganga Prashad, you had asked something about the risk in the beginning. Do you still have that doubt? You had asked about finding the risk, right?
No, ma'am, it's fine. I will approach to that method. No, I will approach to this method only, ma'am. Now we can discuss some other thing also, like activity question and other doubts if others are having.
Okay, so one more doubt. Okay, some Krishna Mohan. So ML estimate of how to find the ML estimate of mu, which is for the normal distribution. Okay. Is it there?
Ma'am, I found out the ML estimate of mu for normal distribution, ma'am.
You found out the ML estimate. Okay, now
Yes, ma'am, I just solved it. You told to find for mu square.
Wait, no, I asked for like what is the ML estimate of sigma square? Like
Sigma
if you
square.
have, yeah.
Okay.
So like
Okay.
if you have the samples coming from the normal mu sigma square, okay. So we can find all these are IID. Okay, let's just assume that. So the first thing that we have to find is ML estimate of the random variable mu. Okay. All right. ML estimate of the parameter mu. So how do you find the ML estimator of parameter mu? So to find the like ML estimate of the parameter mu, first you need to find the likelihood function, right? So it becomes L of x1 up to xn, and this is equal to product of fx of xi's. Now, what is fx of x? Like when x is coming from normal distribution, it is 1 upon sigma under root 2 pi e to the power minus 1 upon 2 x minus mu upon sigma whole square, right? So we have to do the product from I varying from 1 to n, right? So it is going to be I varying from 1 to n, 1 upon sigma under root 2 pi, right? E to the power minus 1 by 2. So x1 minus mu upon sigma whole square. Then you will have 1 upon sigma under root 2 pi e to the power minus 1 upon 2 xn minus mu upon sigma whole square, right? So you can see that this term you are multiplying n times. So you can directly write 1 upon sigma under root 2 pi to the power n product of e to the power minus 1 upon 2 sigma square, right? And it is coming out to be sum of xi minus mu, where I is varying from 1 to n whole square, right? This is right.
Yes. Yes, ma'am.
Okay. So once we find the likelihood function, what is our next step?
We will take a log.
We take the log, right?
Yeah.
Once we take the log, here, so it comes out to be, see, n times log of 1 upon sigma under root 2 pi, then minus of 1 upon 2 sigma square, sum over xi minus mu whole square, I varying from 1 to n. Correct? Now we have to find the ML estimate of mu. So we first, okay, so since we have to find the ML estimate of mu, so in this case, we have two parameters. One is mu, another is sigma square. So how will you differentiate? You have two random variables. So how will you differentiate? Anyone?
We can differentiate with respect to mu for finding mu square.
Yes. So Kevin has answered on the chat box. So we'll have to treat the other random variable, so other parameter as the constant. So in this case, we can treat sigma as a constant and differentiate with respect to mu, only mu, right? So once you treat sigma as a constant, right? So it comes out to be, so let's take this as y. So dy upon d mu is d upon d mu of n log 1 upon sigma under root 2 pi minus 1 upon 2 sigma square sum over xi minus mu whole square. Okay. Now the first term is all constant, so this is going to be 0. You can just cancel it. The second term, so 1 minus 1 upon 2 sigma square is a constant. You can keep it out, and it comes out to be xi minus mu whole square. You have to differentiate now this. So I varying from 1 to n. So d upon d mu. I will clean it. This one, clean this part. Let's see this. So now what is left is this is 1 upon 2 sigma square d upon d mu of sum over xi minus mu whole square, I varying from 1 to n. So what will you get once you differentiate this?
In the bracket, we just go with summation of 1 to n to
Okay.
xi minus mu into minus 1. The constant stays constant.
Yeah. What is going to be inside?
2 into xi minus mu
2 into xi minus mu
into minus 1.
Okay. So it becomes 1 basically.
Yeah, it basically becomes 1. Am I right or wrong?
This is right. Okay, so this is varying from I to n, right? Now this 2 you can cancel and it becomes sum over xi minus mu. So basically x1 minus mu plus x2 minus mu plus up to xn minus mu, right? Divided by sigma square, and this comes out to be 0. So sum over xi minus of n mu equals 0. So once you take it on the other side, your mu comes out to be sum over xi divided by n. So basically, ML estimator for mu comes out to be sample mean. Is this clear?
Yes, ma'am.
Okay. Now, similarly, if you have to find the ML estimate of sigma square, what will you do? So you see that till here, the step is going to be same.
Consider
Right.
with respect to sigma.
Now, once you have to find the ML estimate of sigma square, you will treat mu as a constant. So, do you want to try that out? ML estimate of sigma square.
Binomial.
Sorry.
Let us complete it now.
We'll calculate it here.
Yes.
Okay. So I will just write this term here. So y is n times log 1 upon sigma under root 2 pi, sigma under root 2 pi, minus 1 upon 2 sigma square, sum over xi. now we'll have to differentiate with respect to sigma, right? So differentiate with respect to sigma. What will you get? You will get d upon d sigma of n log 1 upon sigma under root 2 pi minus 1 upon 2 sigma square sum over xi minus mu whole square, I varying from 1 to n. So the first term you have n time log 1 upon sigma under root 2 pi, right? So derivative of log, 1 by.
It is 1 by x, but can you break it now like n log 1 minus n log sigma root 2 pi? Can you break it like that?
Sorry, can you repeat?
The derivative of log x is 1 by x, right? But I'm saying, can we break it here like n log 1 minus n log sigma square root 2 pi? Can we break it in that way? Can we use the formula of log m by n equal to log m minus log n? That's what I'm asking.
Okay. You are saying log a by b, can we write this as log a minus log b?
Can we do like that? That's what I'm asking. I'm not sure, so I'm asking. Because in that case, the first term will become 0, n log 1 will become 0.
That will become 0, and you will have negative of?
Negative of then log sigma root 2 pi. So it will be, I think, 1 by x. Na? So root 2 pi by x.
Something is not right.
Okay. Wait. One n will also be there, man. Yeah, n will also be there.
N is also be there. So this should come out to in the numerator. So we know that log of x comes out to be 1 by x, right? So here log of 1 upon sigma under root 2 pi. So this we can write it as log of, so it is going to be sigma under root 2 pi. Sigma under root 2 pi, and you have the constant term under root 2 pi. So that will get multiplied.
And again root 2 pi. Again root 2 pi, yes.
So it becomes n 2n pi sigma.
Yes.
I don't think this is right.
Yes, ma'am, this is right.
Okay. So in the second term, this you will have to treat as a constant. So you can just pull it out. My minus mu whole square, I varying from 1 to n. And 1 upon sigma square, the derivative is going to be 1 minus 1 by x, right? Yes. So this is going to be 1 upon 2 times sigma.
Sigma k.
Oh no, this is not integration. No. This is wrong.
Ma'am, it will be minus.
It is going to be minus 2 sigma to the power minus 2 sigma to the power minus 3, right?
Yes.
So it comes out to be 1 upon 2 sigma q.
No, 2 will cancel out, no, I think.
Just this one.
Yes, ma'am.
I
Hello.
think we
Yes.
are getting the right answer.
Derivative is correct. Yes.
Anyone has tried this?
Ma'am,
Yes.
we can, when we take the likelihood, that time we can avoid the term 1 by root 2 pi.
This we can avoid this term, right?
Then last we will get sigma I is equal to 1 to n xi minus mu the whole square. That is constant part.
Sorry, can you repeat?
Uh,
What is the log likelihood function you're getting? Like after differentiation, what are you getting?
After differentiation, sigma I equal to 1 to n xi minus mu the whole square into
Xi minus mu whole square. I varying from 1 to n, 1 by sigma cube. This will be there. Then
I differentiate 1 by sigma cube. 1 by sigma square I differentiate. I take
1 by sigma square differentiation will come out to be like minus 1 by 2 sigma square come out to 1 by sigma cube, right?
right. Then 2 to cancel.
So it remains 1 by sigma cube.
Okay.
And
Then
the first term, it will come out to be
plus n by sigma.
n by sigma.
We avoid root 2 pi is not there. Then,
Right. That part is not there.
okay. Then 1 sigma is cancelled. Then we will get sigma square equal to sigma I is equal to 1 to n xi minus mu the whole square by n. When we get to 0, we can cancel.
You equate to 0 and you get 1 by n. Okay, you will get 1 by n sum over xi minus mu whole square, I varying from 1 to n, divided.
Equal to sigma square.
Oh, this is sigma square, right? Sigma square. Yeah. Yeah, we should get this.
I have just question, ma'am.
Yes.
And it is actually question number 4, ma'am. Actually, it's from the assignment.
Question number 4 from where?
From needed assignment.
Question number 4 from which week?
GA 9.
Week 9.
Yes.
Week 9 deadline is not over yet, no?
Yes, ma'am. But that's one question which is like.
Okay, I'll just see like what is there in question number 8. Week 9 assignment.
Question 4 GA 9.
After this, please take activity questions.
I'll share my screen, ma'am.
No. Okay. So what is the doubt there, Krishna Mohan?
Can you open it? Can you open it, ma'am?
I have it here. You just let me know. Like. I have
Yes,
it.
ma'am. So in that, actually, they have given it as a normal distribution. It's a height of people which are normally
Yes.
distributed, and they have given the mean and standard deviation as 40. And random sample, I think it numbers to around 10, I guess. So
Yeah.
anyway, they have given the
So
heights of around
basically,
10 people.
in this problem, you have to find the value of fx of 160.
Yes, ma'am. And it says maximum likelihood is given as mu cap, and it's a normal distribution mu cap on 1. So yeah, we have to find the effects of 160, ma'am.
Yeah, I cannot discuss it here. So just think about it. I mean, you know how to find, how to find the ML estimate of mu that you just saw. So it just you have to find now fx of 160.
Yes, ma'am. How to go about it, ma'am, actually?
I just think about it. It's very easy actually. Like once you find mu hat, it's very easy.
Ma'am, can we discuss activity question?
So mu,
Activity.
first you have to find mu cap, and so once effects of 160 would be for the probability for value x being 160. That is the height being 160. See?
Yeah. Right.
No, for finding mu cap is okay, ma'am. But how to find mu cap? I'll find it out. That step is anyway.
Just think about it. I cannot discuss more.
Okay, so to get to fx of 160, you start from mu cap. Find out mu cap and
Yes.
then go to.
Yes.
Okay.
Yes.
Okay. Thank you.
Okay. So
9.4 question number 4, ma'am.
9.4 question number 4.
You
Okay.
just tell me how to approach, ma'am. Then I will take care. 9.4 question number 4.
You have to find the bias of sigma hat square.
So bias is known that it is expected value of error, right?
Yes.
But when this kind of expression is given like sigma hat square equal to 1 by n, right? So how to proceed from here?
So okay, so it will be expected value of 1 by n sum over.
Could you please solve it, ma'am, at least once?
Sum over xi whole square, I varying from 1 to n, minus of x bar square.
Yes.
Okay, this exact problem has been solved on Discourse also. Did you check that by any chance?
No, ma'am.
No? Can you check there?
Okay. So, okay, ma'am, I will do that. Now, can you come to question number 10, 11, and 12 here? How to approach last 3 questions? Just tell me the approach. Same one.
10, 11, 12. Okay.
Yeah, here population description is not given. Nothing is known about population. Then how to proceed?
Bias of mu hat. To find the bias of mu hat, you need to find the expected value of x1, expected value of 3 times sample mean, right?
And here both mean and standard deviation are unknown now.
But they are given, right? Unknown mean mu, means the mean is given as mu, which is unknown, but we know it is mu.
Okay.
It is easy only.
Yeah, then it can be done. Okay, then it can be done. Okay. And for that, you are saying it is there in Discourse, right?
Yes. So it just you have to find expected value of 1 by n sum over xi, I varying from 1 to n. This minus x bar square, right? And this have to subtract by sigma square, right? This was the question, right? So, 1 by n you can take outside, and it just the expected value of sum over xi square, right? Minus x bar square. So, in this can be written as sum over expected value of xi square, right? minus expected value x bar square. So this will become what? So you know that expected value of xi square is going to be equal to variance of xi plus expected value of xi whole square. Correct? We know variance of xi, this is sigma square. We know this is mu square. So basically this becomes sum over sigma square plus mu square, and I varying from 1 to n. So this is n times this, minus of expected value of x bar square. So what is expected value of x bar square? It is going to be variance of x bar minus plus expected value of x bar whole square. So variance of x bar is, you know, that is sigma square by n. And expected value of x bar is mu square. So this becomes sigma square by n minus of mu square. So sigma square minus sigma square by n, and you had sigma here. So bias comes out to be minus sigma square by n. Right?
Okay, yes.
This all has been discussed before. This
Before means during our term or some other term?
Oh no, this term only, like tutorials. In tutorial, you had come across something like that. Like variance of, we had to find variance of sample, something we had to find, expected value of sample variance. So there you had come across how to manipulate the terms and all. The same thing. Okay. So this is clear, right?
Yes, thank you.
Okay. So
Madam, I have something more fundamental as a question. Would you kindly explain the method of moments and the exponential thing? The 1 by lambda always throws me off.
Exponential distribution method of moment.
Yeah.
So, okay. So let's say the samples are coming from exponential lambda.
Right.
So in method of moment, we know that we equate the distribution moment, the sample moment. So since it has just one parameter lambda, so what is the expected value of, let's say if this is x, so what is expected value of exponential distribution?
It's 1 by lambda.
It's just 1 by lambda, right?
Correct.
And if you have to find the sample moment m1, you have to equate this to m1, and m1 is nothing but x1 plus x2 plus xn by n. So what does lambda comes out to be? Lambda comes out to be n by x1 plus x2 plus up to xn. So our method of moment estimate of lambda comes out to be reciprocal of sample.
1 by x bar. Okay. Okay.
Okay.
All
Yeah.
right. Thank you. Thank you.
Yeah. So I hope quiz preparations are going fine for all of you.
But
Not
one,
really.
but the one we covered just now, the first time I didn't understand method of the estimator with lambda. And
Estimator is not a part of quiz 2.
no, the previous example that you worked out, can you just go back to that?
Okay, you want me to share the screen?
Yes, ma'am. Yes, ma'am. So x1, x2 to xn, exponential lambda. So this I didn't get, man. 1 by lambda. How
So
you got it?
when you have to find the method of moment estimate of a parameter, you equate the distribution moment with the sample moment. So
Okay.
you know that in this case, the distribution moment here, so the sample mean, okay, so sample moment is what? M1. This is given by x1 plus x2 plus xn by n. right?
This is
And
sample new, right?
yes, and what is first moment? This is nothing but expected value, right?
Yes, ma'am.
So what is the expected value of the exponential distribution? 1 by lambda.
Exponential distribution.
For exponential distribution,
Okay.
what is the expected value of this? What is the expected value of x?
Okay,
It is 1 by lambda.
1 by lambda. Okay, exponential distribution. Okay, okay.
Exponential distribution. So all this you will have to keep in mind, like what is the mean variance of each of the distribution. Even if we do not know, like in the exams, we do provide the values, like formulas.
So we have to equate this m1 to 1 by lambda. That is mu.
Yes.
So 1 by lambda equal to this. So from here lambda would be n by, okay, n by x1 to xn, which is nothing but 1 by, okay. So the how the final step will come down here? Method of movement lambda is equal to 1 by, how to derive that from the previous step?
Sorry.
The last one, ma'am. I got the step lambda equal to n by x1
Yeah.
plus
So
x2.
now you will have to equate this distribution moment, the sample moment. So 1 upon lambda is going to be x1 plus x2 plus xn by n.
Yes, ma'am. Yes,
And
ma'am.
since you have to find the MMA estimate of lambda, so basically whatever lambda you get, this comes out to be method of moment estimate.
Okay.
So it just
It will
lambda
be the reciprocal of the mean. Okay.
lambda hat of MME is nothing but n upon x1 plus x2 plus up to xn.
Okay. So the result we get is actually the method of moments, right? That is taken as lambda MME, lambda cap MME, right?
Yeah, right.
Ma'am?
Okay.
Huh?
Yeah, today we solved a question related to exponential distribution where lambda, it was like 1 by theta, right? E to the power minus x by theta, right?
Yes.
Today itself, just question number 5 we solved,
Yes,
right?
yes.
It was 1 by theta, e to the power minus x by theta, right? If, say for example, if it could have been e to the power, theta into e to the power minus theta, then in that case, my answer would have been 1 by 13. In place of 13, it would have been 1 by 13 or what?
If it was lambda e to the power minus lambda theta, then it was 1 by 13, no?
1 by 13, no? Yes. Okay. Then will there be question from week 1 to week 4 also in quiz 2?
You may expect some problem, but not much.
Okay.
Madam, last time you actually helped us prepare for the quiz. Is there something like that being thought about?
Sorry?
Last time you had helped us prepare for the quiz.
Last time I had prepared for the quiz.
Yeah, there was one session on revision. There was one session on
Revision of the syllabus and all that was, that's
Yeah,
what I
week,
meant by
week 1 to week
so
4.
revision session is there this week also. So it is Thursday you have a mock revision session, and Friday there is a revision session. So
When are you going to release the solutions of the mock?
solutions of the mock will not be released. It will be discussed in the live session. So you can watch the session.
Why instance you won't release the solutions for the mock always?
No, like only if we discuss, then after that we release. Otherwise, we don't. Before
It's
that,
okay. After that also, before exam, because the deadline for the exam is Saturday 5 p.m. Before that, do we expect the solutions or no?
Solutions will release only after the session.
After
Not
the
before
session.
that. Yeah.
No, actually the end time is Saturday 5 p.m. for the mock.
Yes. So that you can keep attempting. And we also see that you are attempting the mock.
Yeah, that is okay. But solution will be released after 5 p.m. right? Saturday. Then Sunday is the
No,
exam.
solution we will release after we discuss the mock. Solutions will
Okay.
release. Yeah.
Okay, fine.
Yeah.
And one more thing, I'm writing exams from UAE. During the last 2 exams, facing issue with the calculator. When we enter one time, it's taking 2 times. Like if I enter 2, it's taking 2. Because of this, I lost many marks in statistics because because of the calculator issue only. I wasted a lot of time in stats.
Okay, so I hope this has been fixed. I will just check with the team.
This is 2 times we faced during the first term, end term also, and last time also, first quiz one.
Okay. So
because the
I will check.
statistics only, statistics only needs the calculator help. Even maths, we are not using the calculator because the mathematical calculation part is more in statistics too. I don't know, you guys are testing the mathematical skills of the students, calculation skills.
No, we are not testing calculation, like the calculation part, basically the concept.
The computations are more in statistics and calculation.
It depends on what you are studying. What you are studying in maths. So I guess in maths you are studying linear algebra, right?
Yes.
So there you don't even need calculator. I mean,
that's what for stats only we need calculator. But could you
so
please?
It depends on the topic. Yeah, I will check on that.
Okay, because especially for these exponential values, we cannot do with our hand. Right?
Yeah, that we cannot do. That is right.
And for quiz 2, we can say that stress will be on week 4 to 8, right?
Sorry.
For quiz 2, we can say that the questions will be predominantly from week 4 to week 8, right? Not 9, right? Only week 4 to week 8.
It will be till week 8, not week 9.
Okay.
Week 5 to week 8.
Okay.
Ma'am, week 5 to week 8.
I mean, few questions you can expect from week 1 to 4. So, yeah.
Ma'am, please don't give those lengthy calculation of standard deviation, correlation, coefficient, and all.
No.
It takes too much time. Last time also there was one question on standard deviation.
Standard deviation.
Yeah. Last time there was a question on standard deviation. It took at least 10 to 12 minutes. And generally they commit some mistakes when calculating that.
Which question was that?
I think tossing some question was there, maybe I don't recollect it. I made it correct finally.
There was something to find the variance, I remember.
Something like that, ma'am.
But that was very, you don't even
No. That point variation, that was very easy. I'm not talking about that. There was a lengthy calculation, ma'am. But leave it. I'm just requesting.
We make sure that the calculations are not lengthy.
It's your prerogative. We cannot, ask on that. Ma'am, will you take a question from week 4, ma'am? 4.2, question number 7, 6 and 7, ma'am. It will not take much time.
4.2, question number 6, 7.
Activity questions, ma'am.
Okay. Yeah, what is the doubt?
Ma'am, this y is defined as x minus mu by sigma, right? So this is the way we define, standard normal random variable, right?
Yeah, right.
So then if y is the distribution of y, then which of the following option is true? So this shuffling, I am not able to make it. This manipulation.
So you have to find the CDF of y. So Fi of y comes out to be probability y less than equal to y. So what is y? Y is your x minus mu upon sigma. This you're saying it is less than equal to y. Right? So this you can write it as probability that x is less than equal to sigma y plus mu. So it becomes fx of sigma y.
Come again. What did you say? Yeah, up to that point it is clear. Fy of y is equal to, it is less than equal to y, right?
It is you have to find fy of y, and this is probability y less than equal to y, right?
Yes.
And y is x minus mu upon sigma. It is less than equal to y. Correct. And this you can write as probability x less than equal to sigma y plus mu. So this is some x, right? So this is a random variable x. This you can write fx of sigma y plus mu.
Okay, ma'am.
Yeah, because this is some value, right?
Yes, lot of manipulation. Yes, and then 7, ma'am.
7. Let me check what is in 7. Seven also you have to find CDF of geometric distribution. So how do you find the geometric distribution CDF? I mean, any CDF for distribution.
CDF, we go by integration, ma'am. We know the PDF, we integrate PDF to get the CDF.
Yes.
Okay, so the
So
same
what?
logic.
Yeah, same thing. You just write out.
Yes, so the same logic I have to apply, right?
Hmm.
Okay, ma'am. Okay. Ma'am, generally we have a session on Sunday. Please don't keep this, this Sunday.
No. This Sunday will not be a session.
Keep it on Monday, ma'am. Keep it on Monday so that
last time it was a mistake. So.
No, you can reschedule it on Monday, ma'am. You can plan it on Monday so that we should not.
Okay, yeah. Okay, so yeah. Okay, all the best, all of you. Like prepare for quest 2 properly.
Thank you, ma'am. We are meeting on Thursday, right, ma'am?
We are meeting on Thursday, then Friday we are meeting. Yeah, but prepare for the quiz. Okay. All right. We'll close the session then. Okay. Yeah. Bye all. Good night.
Okay, ma'am. Thank you. Good night.
Thank you, ma'am.
Thank you, ma'am.
Thank you all. Thank you. Yeah.